capacity approach for events. So here power quality mainly concern on two topics, one is interruption and one is voltage dip. Okay, so here quality of supply. So for example, if you take any equipment mixie, so per year how many times it gets problem. Okay, based on that you decide how mixie is good, right? Here also similarly quality of supply, it is characterized through the number of events. So number of problems or number of faults get during per year with a certain characteristics, right? So some benchmarking studies have been performed mainly for the interruption, but there are no acceptable limits. So some countries, what they do is use national requirements on, so they do that maximum number of interruption and maximum duration of interruption. Okay, so maximum number of interruption and maximum duration of interruption, right? So some countries use a national requirements on the maximum number of interruption and maximum duration of the interruption. So yeah, how many times how maximum interruptions when it will happen and how many interruptions it will happen, what about the duration of that, right? So based on that, that will be considered for as a indices and limits. Okay, to determine what, to determine the hosting capacity. So here, to apply the hosting capacity approach for events, it requires the development of new values, limit values. So here what they have given hosting capacity concept for power quality events. So dip frequency, that is a existing event frequency. So horizontal axis, this axis, it is a dip frequency, that is a existing event frequency, that means a number of dips per year for a given site. So this is a vertical frequency, that is after, this is after distributed generation is included. Okay, for example, frequency may change after including the DG. This is without during the fault, and here DG is not there. Okay, you can observe it is 0% of DG and here X percentage of DG. So here for points at the diagonal solid curve, so this is the diagonal solid curve, above is acceptable deterioration and unacceptable deterioration, below quality of supply is improved. Okay, so below what they do, quality of supply is improves. So here it will be same for both the frequencies. This solid curve for both event frequencies are the same, and the introduction of DG does not have impact on this. Okay, so here the three basic limits are there. One basic limit is, for example, 50 frequency will be there. So in increase in event frequency, what they have given is the basic limit is maximum percentage increase in event frequency, 100% increase in the figure. So no twice the existing level, no twice the existing level. So no customer should see more than this percentage increase in the event frequency. For example, 50 Hz is the standard, right? So they kept the standard, and that should be there. It should not become 100 Hz. Okay, it should not become the twice the existing level. So that is what they have given in the figure. This is the standard frequency, 50% below this one. Okay, so the 100% will be there. Okay, this is the twice existing level, so this will be that. So twice that should not go above during the fault condition. So no customer should see more than this percentage increase in the event frequency, right? Next is an absolute limit is introduced to prevent an excessively high event frequency for these sites with the highest event frequencies in the existing system. 110% of the maximum existing event frequency in the figure. So what they do is, so next to this, an absolute limiter, you can observe 100, 110 percentage. Okay, an absolute limit is introduced to prevent an excessively high event frequencies for those sites with the highest event frequencies in the existing system. 110 percentage of the maximum existing event frequency in the figure. So that should be applicable, okay, acceptable. So that should not go behind that. Again, a 110% is acceptable. That is the maximum existing event frequency. That is the limit. So the next limit is what they have given for site with a very low event frequency. That is, for site with very low event frequencies in the existing situation, a small absolute increase in will translate into a large relative increase. So here the example used in this figure is half of the highest event frequency for the existing site. So this one, 50% off of the highest event frequencies for the existing site, that is 50%. Okay, so that is the limit for a site with very low event frequency. That should not go below that one. Okay, so it should be 50%. That too for a low event frequency. For site with very low event frequency in the existing situation, a small absolute increase with will translate into a large relative increase. So that too, the example used in this figure is half of the highest event frequency of the existing site. So that is about the approaches for hosting capacity approach for events, right? So next, for power quality variations, only an absolute limit is used.